let's see. How do I identify that this is, because I recorded this. This is period 7. Okay, now, this is going to be the worst recording ever. Okay. A rock is dropped off a cliff into a lake. You hear it splash into the water 3.2 seconds after you release it. Draw a picture. List knowns and unknowns. How high is the cliff? How fast is it going before it hits the water? So, first thing you need to do when you have a diagram is you need to draw the situation. / draw the motion. So draw the object and what the object is doing. A rock dropped off a cliff into a lake. And I mentioned to draw the motion. Well, what's the rock going to do? It's going to fall. There you go. Once you've drawn that, the next thing you want to do is label the known values. So I look in the problem, and I see 3.2 seconds. So that's a time. Now, time is hard to draw because it doesn't have a direction. So the way I draw time is I make a little bracket starting where it was and going to where it hits. And I write t equals 3.2. There's nothing else to label because it doesn't tell me a velocity, it doesn't tell me a height, it doesn't tell me an acceleration, so there's nothing else to label. Okay? The third thing I need to do is I need to decide positive and negative. So this is why we're drawing the diagram, because this is something we have not done yet. We have always assumed forward is positive and backward is negative. We have never picked the direction of positive and negative. You want to pick a direction to be positive and negative. And it's very easy to do that. What you do is off to the side, you draw an up and down arrow, and you draw which way is positive and which way is negative. So let's go ahead and do what we've normally done. Down is negative, up is positive. Let's go ahead and do that. I'll come back to what would be if you did it differently. But let's go ahead and do that. So decide what your positive and negative is, and then the last thing you want to do is draw the acceleration, which is always going to be down. A is always down. But it's important to draw for reasons which I will explain shortly enough. So, draw the situation and the motion, label the known values in the picture, decide what's positive and negative, up or down, and then draw acceleration. There you go. That doesn't look bad with everything in purple except for that. Oh, it actually looks like I highlighted it. Nice. Okay. Next, list your known values and your unknowns. I know time is 3.2 seconds. I know nothing else. I know how high is the cliff. That's D. I'm solving for displacement. How fast is the rock traveling before it hits the water? So that's VF. How fast is it going right before it hits the water? This is a problem. I'm trying to solve an equation where I need 4 things, and I only have 1 known and unknowns. That's it. I have to know VI. I've got to know A. I can't solve for these if I don't know those values. But good news. You do know them. All right. Who's feeling their big old brains that can read between the lines? Jacob, tell me one of those 2 what you think it is.
VI would be 0.
Tell me why. You're right, it is.
Because the rock is being dropped.
Yes.
Usually that means it's stationary.
Yep. Unless I say thrown, VI is 0. If I drop something, it's 0 for VI. It starts at rest when I let go of it. Unless I say threw, I either throw it down or throw it up. But if I don't throw it, its VI is 0. Excellent. Somebody else, what do you think A is? Lucian, what do you think? What do you think A is going to be? Okay? Davida? So you're close. It is going to be constant. It's just not going to be 0 here. That's a good guess, though. Ethan? It is 9.8. Ethan, pin the tail on the donkey. Okay? It's 9.8. In fact, it's always 9.8, unless I say otherwise. So, even though it looks like I didn't give you enough, I only gave you a time, I actually gave you 3 things. I told you it's falling, which means A is 9.8. And I told you it's dropped, which means VI is 0. So, let's solve this now. How high does it go? So, T, VI, A, and D. So, we need an equation that's got those 3 things. T, VI, A, D. All right? Old Faithful. T, VI, A. Okay, that one's out. T, VI, A, D. A big win for the big chalupa. So that's the equation I'm going to use. Now, here's where we got to start be careful. God bless you. We got to start thinking about directions. Up is positive, down is negative. Anything up, we need to make positive. Anything down, we need to make negative. So D is, I don't know. I don't know the value, so I'm just going to write D. VI is 0, so it's just 0. Time doesn't have a direction, so it's just 3.2. Plus 1/2. A is down. That's why I drew it in the picture. That means down is negative, so it's a negative 9.8. Okay, and then 3.2 squared. So 0 times anything is 0, so this goes away. 3.2 squared is 10.24 times negative 9.8 is negative 81.92 times 0.5 I don't like how that turned out. I did something wrong. 3.2 squared times 9.8. There we go, times 0.5. I got negative 50.2. And that makes sense. It's falling, so it should be a negative answer, because I said down was negative. Okay? Now we need to solve for how fast the rock is going, so I need VF. I'm going to go ahead and use ain't got no time. That's got VF in it. So VF squared equals VI squared plus 2AD. So VF is what I'm solving for. VI is still 0. Plus 2 times A. Remember, down is negative, so it's negative 9.8. Okay. D is negative 50. You can see, if I forget to make one of these negative, wow, way off. If I forget to make one of these negative, I'm going to be in trouble. I'm going to get the wrong answer. I have to make them both negative because both of them are down. So negative 50.2 times 9.8 times 2 gives me V final squared to be 983.4. Square root both sides to get V final by itself. 31.36. But be careful. When you square root, you actually get plus or minus the answer. So which one is right? They can't both be right. It's actually a negative 31 because it's falling, and I said down was negative. Now, do I have to call down negative? No. In fact, if you're asking me, Mr. B, what do you make negative? I, for this problem, I would make down positive, and I would make up a negative. And here's the simple explanation for why I would do that. Because everything is down. Nothing is going up on this problem. Nothing. Not a single thing is going up. So I'm saying to myself, if I can pick up or down to be negative, why don't I make down positive? Because then it's not negative 9.8, it's positive 9.8. It's positive D, it's positive V. Everything is positive. Okay? It's like a happy Lego movie kind of a thing. Everything is positive. Now, is your answer wrong if you get all negatives because you made down negative? Of course not. That's fine. Is your answer wrong if you make down positive and you get all positive answers? No, it's fine. Here's where your answer is wrong. If you make down negative and you get positive numbers, then it's wrong. Or, worse yet, if you don't tell me. If you don't tell me what's positive or negative, I'm just going to have to guess. And you don't want that. You don't want me to guess. Not on your answers. Okay? You don't want me to guess. So it's important that you decide what's positive and negative. So that's going to be something I'm going to look at a lot today. Decide what's positive and negative. Now, I can feel some of you saying, Mr. B, I am never going to remember what's positive and negative. Okay? If that's you, here's what you do. Ready? Always make down negative. If you're worried, always make down negative every time. Draw this, down negative. Do the problem. Draw this, down negative, do the problem. If you're worried that that's going to happen to you, always, always, always make down negative. But if you're a person that are like, oh, Mr. B, I think I can do this, then do that. That makes life easier for you because then you can decide what you want to make the problem work easiest for you. All right, let's knock out number 2 here, and then we'll let you work on the practice. Oh, yeah, we're in good shape. Number 2, what about objects that are thrown up into the air? So here's a couple of notes about things that go up. So first of all, VI is not 0. And it's up. Okay, it's not 0, but it will be up. Again, only for things that are going up. Second thing, VF equals 0 at the max height. Only at the max height is V final 0. Anywhere else you look, V final will not be 0. But at the max height, it will be. And lastly, A equals 9.8 still. And it is still down. Whatever direction you call positive, A is still down.